Welcome to the DIY Honda Garage channel. This presentation discusses Diagnostic Trouble Code B1168, which indicates a loss of communication between the Gauge Control Module and the Engine Control Module, ECM, or Powertrain Control Module, PCM, in the Honda Civic models from 2006 to 2011. The significance of this error lies in its potential impact on the vehicle's ability to accurately monitor and relay critical information such as speed, fuel level, and other important parameters essential for safe and efficient driving. The relationship between the Gauge Control Module and ECM/PCM is crucial, as these components must communicate effectively for the vehicle to operate smoothly. When there is a communication failure, it can lead to inaccurate readings on the dashboard, potentially causing confusion for the driver. Understanding the components involved and the diagnostic steps required is vital for effective troubleshooting. Therefore, this presentation will guide you through the detailed process of identifying and resolving this issue. The Gauge Control Module primarily functions to manage and relay information regarding the vehicle's performance, such as speed, fuel levels, and engine temperature, directly to the dashboard display. It is typically located in the dashboard area, where it receives input data from various sensors throughout the vehicle and communicates this data to the ECM or PCM, which manages engine operations. The ECM, or Engine Control Module, is responsible for various engine management functions, including fuel injection timing and air-fuel mixtures, whereas the PCM, or Powertrain Control Module, integrates the functions of both the engine and transmission controls. Any disruption in communication between these modules can prevent the Gauge Control Module from receiving crucial information, resulting in DTC codes like B1168 being triggered. This error may be accompanied by other fault codes, particularly in the fuel and emission systems, which necessitates a comprehensive diagnostic approach to ensure a thorough assessment and facilitate effective repairs. Several factors can lead to the occurrence of DTC B1168. One primary cause is loose or poor connections between the Gauge Control Module and the ECM or PCM. These connections are essential for reliable communication, and any corrosion, looseness, or disconnection can disrupt signals. Additionally, a faulty Gauge Control Module might result in communication failure, which would require inspection or replacement. Another possible cause could be outdated software in the ECM or PCM. If the control units are not updated to the latest version, it might lead to compatibility issues with the Gauge Control Module. It's important to investigate the specific conditions that triggered the error as well, as environmental factors or modifications made to the vehicle might also contribute to these issues. Each of these causes should be thoroughly evaluated during the diagnostic process to ensure accurate repairs and prevent recurrence. The symptoms associated with DTC B1168 can significantly impact the driving experience. One common symptom is inaccurate dashboard readings, which may display erroneous information regarding speed, fuel level, or engine temperature, potentially leading to unsafe driving conditions. Additionally, warning lights may activate on the instrument cluster, signaling to the driver that there's a problem with one of the vehicle's systems. It's also possible to experience intermittent performance issues, where the vehicle might operate normally at times and then exhibit erratic behavior at others, complicating troubleshooting. If the communication loss escalates, it could lead to a total failure of the Gauge Control Module, resulting in no readings at all. Recognizing these symptoms early can help in conducting timely diagnostics and repairs, preventing further complications down the line. The first troubleshooting step for addressing DTC B1168 involves clearing the Diagnostic Trouble Codes, DTCs, using the Honda Diagnostic System. HDS. The HDS is an advanced tool designed for diagnosing and troubleshooting Honda vehicles, allowing technicians to communicate effectively with the car's computer systems. This initial step resets the vehicle's fault memory, which is crucial for determining if the error is persistent or an intermittent issue. After clearing the DTCs, it's essential to prepare for the status check by turning the ignition switch to the lock position and then back to the on position. This action primes the electrical systems and allows various modules to initiate their startup sequences. The next step will involve waiting for approximately 6 seconds to ensure that the systems stabilize before checking for any active DTCs once again. By following this process closely, technicians can accurately assess whether DTC B1168 is still present for further investigation. In the second step of troubleshooting for DTC B1168, technicians will recheck for any diagnostic trouble codes using the HDS. This check is critical as it helps to reveal whether DTC B1168 or DTC B1169 is still indicated after the codes were previously cleared. If either DTC is present, it signifies an ongoing issue requiring further action. Conversely, if no codes are present, this may indicate that the problem is intermittent, which suggests that the system might be functioning correctly at that moment. However, it's also important to investigate potential loose connections or other anomalies that could trigger intermittent failures in the future. This step lays the foundation for the next phase of diagnostics, allowing for targeted repairs based on the outcomes of this check. The third troubleshooting step involves checking for any fuel and emission system-related DTCs with the HDS. This ensures that any additional codes related to the fuel and emission systems are identified and addressed. These systems greatly influence the performance and emissions of the engine, and they can also affect the functioning of the gauge control module. If any DTCs are found during this check, remedial action should begin based on the specific codes identified. This could involve further diagnostics on the fuel system or emission controls, as they often interlink and can indirectly influence communication with the gauge control module. In scenarios where no DTCs are indicated, technicians can move forward to the subsequent step, confident that the fuel and emission systems are not the primary issue and maintain focus on the communication problem. In troubleshooting step 4, the next immediate action is to turn the ignition switch to the lock position. This step is crucial as it ensures the vehicle's electrical systems are powered down, preventing accidental damage to electronic components during the diagnostic process. Following this, the gauge control module's 36P connector must be disconnected. This operation isolates the module from the remainder of the system, allowing technicians to run continuity tests without interference from other components. Technicians must pay careful attention while performing this step to avoid causing further issues. This preparation is vital for establishing a clear pathway to test communication integrity between the gauge control module and the engine control module, ECM, or powertrain control module, PCM. Success in this step sets the groundwork for performing subsequent continuity checks and determining the cause of the communications failure. The sixth troubleshooting step requires jumping the SCS line using the Honda Diagnostic System, HDS. The SCS line, or the Security Communication System line, is an essential communication pathway that allows the technician to perform diagnostics without interference from the security features in the vehicle. This function allows for focused communication with the ECM or PCM during troubleshooting. After joining this line, the next move is to disconnect ECM/PCM connector A, which contains 44 pins necessary for communication with various system components. This action is also instrumental in isolating the ECM and assessing its function about the gauge control module. Proper execution of this step allows for a comprehensive examination of the communication lines, which is essential for diagnosing any wire issues or module failures. In the 7th troubleshooting step, technicians will check for continuity between the gauge control module's 36P connector terminals and the ECM-PCM connector A. Specifically, continuity needs to be tested between terminal number 1 and number 19 on the gauge control module side, relating to terminals number 36 and number 37 on the ECM-PCM. This test is crucial to establish whether a proper electrical connection exists between these components. A successful continuity test indicates that the connection is intact, while failure to establish continuity points to an open circuit somewhere in the wiring. Proper attention to this test allows technicians to either diagnose if the ECM or the gauge control module needs updates or replacements. Therefore, meticulous attention to detail throughout this function is necessary to derive accurate diagnostics, leading to effective resolutions. The final repair verification step is critical to ensure that all required repairs have been successful. After addressing any faults or replacing components, it's important to reconnect everything and check for any new diagnostic trouble codes, DTCs, using the HDS. This verification helps confirm that the previous issues are resolved and that no new faults have emerged during the repair process. Testing the functionality of all systems, including the gauge control module, ECM, and electrical connections, ensures everything operates as expected. This step grants assurance that the vehicle is now safe and reliable for further use. Recognizing the vehicle's operational status and validating repairs are key determinants in successful troubleshooting and repairing processes. Preventive maintenance plays a vital role in avoiding future occurrences of DTC B1168. Regular inspection of electrical connections helps to identify any signs of corrosion or loosening that could disrupt communication between the gauge control module and the ECM. Moreover, it is crucial to routinely check that the ECM and PCM software are updated to the latest versions. Software updates often include improvements and bug fixes that can enhance communication methods and eliminate errors. Periodic system checks using the HDS allow technicians to identify early signs of potential issues before they escalate into larger problems. By integrating these preventive measures into regular vehicle maintenance routines, vehicle performance and reliability can be significantly improved, reducing the likelihood of future diagnostic trouble codes. In conclusion, diagnosing and resolving DTC B1168 is crucial for ensuring the reliable performance of the Honda Civic from 2006 to 2011. This error indicates a breakdown in communication between the gauge control module and the ECM or PCM, which can jeopardize important vehicle information. Understanding the components involved, potential causes, and the systematic steps required for troubleshooting is essential for effective diagnostic procedures. The process outlined, from clearing DTCs to performing continuity checks and confirming repairs, provides a structured approach that simplifies diagnostics. By following these steps, technicians can successfully navigate through the complexities of electrical issues and ensure vehicle integrity. Implementing preventive maintenance routines can further safeguard against future communication errors, thus enhancing the overall performance and safety of the vehicle. Please like and subscribe to the channel. See you next time.